So this is assignment 7. There were some technical problems with the lecture on Tuesday night, so I wanted to make a few corrections by updating the video. So we started the conversation kind of with choosing the stock size. Whatever machine we decide to run, we have to take into account this large diameter, 3¼ by 5 inches long. And so one of the questions was, are we going to be able to get material? So I went on to the industrial metal supply and then into the McMaster car. And, both were 3 1/8 and 3 3/8. And then as the upper lower, the 3 1/4 then showing plus or minus 34 thousandths. That's not going to be a good strategy for our holding our tolerance if it actually came in with under 34. So we'd probably want to go to the 3 3/8. We picked the 3 1/2. So if you have 3 1/2, stay with it. And then, for 6-inch long piece, we could pick if that's going to be enough material to hold on to, an inch, 3/4 an inch to an inch. And we're not doing any, I don't have to do any serious hogging on this, but, if we get aggressive into the end of the cut, then, we want to be concerned about how much material. So if there's, say 3/4 an inch of material left, or we're holding on to 3/4 an inch material, and there's about an inch of material over on the length, then we're either going to have to saw cut that or flip this around in the lathe and do a couple of facing passes to remove that material and bring it to length. So whatever our strategy ends up being, we picked the stock. One of the issues that I ran into was the rectangle. So we're making a stock size that's 3 1/4 by 5 inches. And the axes, I wanted to say that there was a way, and that was one of the things I was looking for, was an axis that would allow me to set the D and the X, or D and the Z, or the X and the Z, and without going into the lathe right away. But that didn't I didn't run across that. So we're going to pick the default lathe, and what that does is it changes our axis to Z going left and right, and then the diameter in what would be the Y direction. All right, so we don't really need to do anything with the tool paths right now. We're just going to jump back into the wireframe. So what that does is put us into a diameter mode. All right, so if I draw the rectangle and then tell it we want the position. So what I was looking for was on either the height or the width, that it would take into account the diameter, and that didn't seem to be the case. So if I told it was 3.25 in height and 5 inches long, and let's go ahead and lock those, then it still pretty much showed up as it would normal. Since we only need half of this rectangle, we only need to have the half profile to be able to do the machining. To turn this part, I don't really have to have the full 325. So in this case, I'm going to go ahead and divide by 2. It gives me the 1.625. My corner isn't exactly where I want it to be, so I'm going to switch this to a negative. And then when I hit tab and come back out into the work area, click on the corner, now I have a basically the radius of the part and the length. So if I click on that, go to F4 for the analyze, then the D value is 325. The length of the line is 1.625. So that verifies my number. All right. So one of the other things that I got hung up on was you get into that mode on the mill of picking endpoints, is that when we're setting up for this geometry, that I would like to go from point to point, and then we're going to do a number of trims to clean this out to get the desired profile. And now look at it. It also looks like I forgot the chamfer on that one. So when the video switches over, that chamfer is probably not going to be there. Alright, so we want to go to 1.25, 1.75, and 2.5 as our numbers. So for the line endpoints, specify the first endpoint. I'm going to force these to be horizontal. And we're going to go from endpoint to endpoint. And then where I got tripped up was on the D coordinate. It's now asking me to enter the value. So 1.25. And then first endpoint will go from endpoint to endpoint, and then the D value 1.75 and enter. And then I can just use the same two endpoints, and then we'll go to 2.5 and enter. Right. So I made that way too complicated, which is easy to do, but follow the on-screen prompts, go through the process, and we'll we'll get through the geometry. So for the horizontal, what would end up being the vertical lengths, the horizontal distances, I'm going to offset the entity, and distance of our first item is 1.375, and we pick the line and set the offset, and then I can pick the line again and 0.375 and side to offset, and then we'll go a total of 3.125 from the first. And since I didn't get the value in because I haven't accepted it, I can go ahead, not 5/16, 3.125, there we go. And then hitting the check mark locks it in, or clicking out into the open area. Alright, and then the last one was 1.25 from the end. So offset 1.25, and then the direction, and that gives us our geometry. Alright, so the wireframe will go line from endpoint to endpoint, and the first chamfer was here to here. Now I'm locked into horizontal, so it's just going to overwrite that line unless I go back to freeform. So I want to make sure that I'm getting that kind of rubber band effect. Looks like it's snapping to the grid. I want to make sure it snaps to my geometry. Okay, so we'll go ahead and accept that. And then we're going to go to trim, break, and extend. So the divide, delete entity, I'm just going to go through, and it's a lot of picking, but I still think it's probably about as easy as anything to get the geometry in place. So we have the steps. And not that one, let's undo, Control Z. Alright, that gets me my my outside shape. And then the fillet entities, we're going to go with 0.25 in two places, so that's going to be over, and pick both entities, and then we'll go ahead and accept. Alright, and then the chamfer entities was a 0.0625, and 40, we'll stay with the distance and angle, 0.0625 by 45 degrees. Same thing, pick the two items, and now we have the geometry. Alright, so under the files, we're going to see the same types of things. What do we want to output? Except we're going to see the lathe tool library. We're going to see the post and the control for the lathe. Tool settings, pretty much the same thing. I want to assign, and based on our tool numbers, and then let's go into the select like we normally would. We'll do the lathe library. We're picking the same aluminum 6061.
All right, and then the stock setup, this is where it gets a little different. We're going to be working from the top plane still. The left spindle, not defined, we go into its properties, and then we're setting a stock. All right, so the 3.25 is our material enough oversized, and is it round enough? Probably not. And then in that kind of diameter, are we going to be able to find 3.25, or are we going to have to go to 3.5 to even get to material? So it's one of those cost versus machine time. All right, since I'm not looking at my my material website off the top of my head, let's just assume that we have 3.5-inch material, because then we have to deal with the stock. All right, so we're going to put in an OD of 3.5. If I tell it that the length, okay, maybe we're doing bar stock, that would be a really big bore machine. So at 5 inches, might be able to get away with, depending on the size of the machine, might be able to hold two pieces and flip them around. But with all that geometry, probably not too well. So let's just say that we're going to go with 8, and we'll figure out the lengths and the geometry later. All right, so it is a cylinder. It's in the number 7 color, and let's just go ahead and accept. Oh, I wanted to preview. So preview the lathe boundaries. All right, so it's showing me, and then notice too that I pretty much just put the stock right on the face of the part. All right, so if this is a saw cut, if it's whatever, I have to take that material, or if I had to take multiple passes, since the system doesn't see the material there, there's a possibility that it should take 2 or 3 cuts if I tell it to, but at least in the simulation, we're not going to have that same visual. All right, so enter to get back into, and so the position along, let's just say we have 30 thousandths. And when I update that, it takes my stock boundary and moves it out just a little bit. Right? 0 is still interior of the part, where the origin is at, but we've just added some material so that it will show up correctly on the simulation. All right, chuck jaws. And if you want to see the chuck jaws, then you can pick. And let's see, user defined position, diameter is 3.5. And the Z direction, let's put them out at -6. And we'll preview again. So as far as the stock, we're holding on to some material. Visually, it looks like that's something that we can cut. All right, so there's material there and gives us a visual reference for the jaw. Now, if we want to go into more detail, then we would find the jaw width, the width steps, the thicknesses, do something that is a little more representative. And then also notice that on the clamping method, you can do the OD, ODs, and then IDs, and different jaw configurations for your stock for that visual. Okay, and then I'm just off screen enough. I'm not sure what happened to my screen resolution. Okay, so we accept. And then that will give us the geometry to start cutting with. All right, so let's just go ahead and do a fit. All right, so if you don't know what tools you have in the library, so on the one hand, the axes, the programming is enough easier. One of the things that I find more difficult is when you open up the tool selection and as far as purchasing, there are thousands of combinations, right? Where you don't have that in the mill sizes, you have some variations on it. But when you get into the tool holders, you get into the inserts, the side relief, in relief, back rake. Does it have a what size nose radius? What size chip breaker? What size? All of those play a part. And as you get more exotic into the materials, some of those combinations are not going to cut well at all. Right. So one of the things that is important to our tool library, which I'll do after class, is to actually walk out to the machine, see what tools are available or what tools are loaded into the machine and their stations, so that we can build a library if we wanted to cut this, where those tools are already situated. All right, and then this is assuming all OD methods. So we may come back and put a tapped hole in as an example, which you can do optionally. All right, so lathe tool paths, and one of the things that, depending on the post and the geometry, because we're going to need more detail, is that if we load up a post that is mill turn, we're going to have those capabilities to do the live C. So it's still showing us the mill options, or on the other side is if we add another machine group, and that machine group is for mill, we could continue to program this part for a next setup. If it had a mill fixture or something along those lines, we would be able to include the milling operations in this same file without mixing and matching. All right, so the lathe tool we want to face, and face is pretty straightforward. One of the things I would say is that if you are in doubt, you're probably better off staying with, correct me if I'm wrong, but like the 85-degree insert, the flatter insert, because if you're going to make a mistake, you don't want the 35-degree insert with all kinds of clearance, telling it to dive into parts and around radiuses, and then all of a sudden find out that you don't have the clearance. So if I'm going to watch the simulation and be looking for this, the backside of the tool holder to come into collision, and I'm not sure what tool I'm going to use, I'm going to program this one so I can see it. All right. Then when I find out in the tool library, oh yeah, station number 5 is always going to be this 35-degree insert or 55-degree insert, then I'm going to build that in and make it part of my my library. All right, so staying with their tool 0101, and so same thing is in a sense the same thing as the mill, but you can have the tool number, and then the offset number is picked up separately or secondary, and can be built into that strategy. All right, so feed rate is in inches per revolution or in inches per minute. We can also tell it to go over to, as far as RPM, constant surface speed. So 10 thousandths for this tool is fairly aggressive, but should be able to handle it depending on what we tell it for the depth of cut. Since the material is sticking out about 6 inches from the chuck so that we have that clearance, but it's 3 1/4, we're not getting into really small geometry. We're always kind of playing that balancing, having that balancing act of, as those diameters get smaller, I'm generating more tool pressure. I'm pushing, that tool is pushing the material away, and we run the risk of generating more of a conic than a cylinder. So we want to be able to make sure that we have the rigidity in the setup and the material before we start taking these really aggressive cuts. So constant surface speed at 200 surface feet per minute, a little on the light side. You know, I don't know that, you know, most mills are going to top out between 3,000, and if you go high speed, they go 6,000. And for a big chunk of material like this, that's a little scary. So hopefully we don't want to calculate something that starts off at 3,000 RPM with this much rotating mass. So most all of the lathes that I've seen have that little warning on it that at higher RPM, your hydraulic clamping pressure is reduced. You should heed that warning faithfully.
Some actually have recommended spin speed
for
chuck that's with.
Right. And so if you have those recommendations, heed them. You do not want this thing getting out of the chuck. We're relying on that hydraulic pressure to hold it in. If you are on one of the manual chuck machines, then it's up to you to snug it, tight it, be confident in it. But even then, under the right conditions, vibration, harmonic, inducing chatter. Just because you torque the hell out of it doesn't mean it's staying in the chuck. All right, so respect the machine. All right, so we'll bump this up and see what we get for RPMs. I'll go to 500 surface feet, since that's about 2.5 times the high-speed steel calculation. If I start seeing elevated numbers in the posted code, then I'll back it down. So our max spindle speed, not 10,000. We'll start off with 3,000, and then even some of the machines are going to be 2,000. So just again, find out what the specifications are on that equipment. All right, so showing the library tools, these are kind of the default tools. If you want to dig in deeper, you can select the library tool that will open up the library. You can go even further. Let's see, we ran through those. Is coolant on or off? And then the home position, do you want it to return? Well, most machines, especially with extended travel, I really don't want to send this 24, 40 inches back home. I want it to go to where it'll clear and set a home position that is clear of the chuck, clear of the stock, and clear of the longest tool. So that when it indexes, we're not coming around slamming into something that we didn't want to intend to slam into. So diameter-wise, 10, if I have 10 inches on the travel. And so the D of 10 inches and the Z. All right, so from machine, a user-defined location, or from tool. Because the machines kind of approach this a little different, or because everybody's going to have their preference, I would say try it out, read it into the post. If it looks like something that you would normally use, make that your default. Stay with it. Things like the miscellaneous values. Well, we have all of these other, just like in the mill, have all these other things that we can write in if there's something specific to the machine. And then the canned text, pulling up optional items, all right, being able to insert those. Where do you want it, before or after? All right, so I can put in op stops after each operation. Some of the posts will do that automatically. If they don't, this is your opportunity to put them in. All right, and then we told it to do the stock update. So as it removes material, it's going to change that stock profile to show us what material it removed. All right, so face parameters. We said we've got a pretty square saw cut, so we shouldn't have to do too many passes. But if we need to, we can tell it to include multiple finish passes. All right, so an entry amount of 100 thousandths, that seems reasonable. The finish step over at 10 thousandths, an overcut amount, and the retract amount. So the overcut amount is when the tool gets to center, to the center line of the stock. Does it keep going, or does it potentially leave that little nub right at the center location? All right, if we have a large nose radius on our insert, then we would want to overrun maybe 30 to 60 thousandths to make sure it cleans up all the way across the face. So let's see what 30 thousandths looks like. Retract amount coming out 100 thousandths, and no stock to leave. If we need compensation, most of the time, depending on how we're doing the loading and unloading, I'm not overly worried about wear for a facing operation. So we'll stay with computer. If we want a specific lead in and lead out, you can check these boxes and kind of go through each of the items and pick. So like tool inspection, if you have the automatic probing, tool inspection will put the check tool position and look at the cutting conditions, or look at verifying that the tool insert is still there and that it is staying within tolerance. All right, so we update, we see the blue line, it comes down, it removes that stock, it retracts, and then the overcut, after it finishes the overcut, then it retracts and goes back to our clearance. All right, so going into the roughing pass, and tell my habit is to jump into the mill tools. All right, we're going to go into the rough, and we need to set the chain. So it's set at partial. We're going to pick the first one and then the last one. Since they're all connected and there's no depth, no branches, it's just going to find the last, and then we'll go ahead and accept. All right, so staying with the same tool for the roughing pass, we're at the 10,000ths. Now I didn't think about the facing operation. 10,000ths is probably a little. We're going to end up with a little bit of spiral now that I think about it. All right, I get kind of locked into that mode of roughing and you know, on the diameters, but when you think about the face, if that goes in too aggressive, and since we're at constant surface speed, it will hit the max RPM that we allow it, that we tell it, as it gets to center. So if I set a max RPM of 3,000, it's going to probably get somewhere into the last quarter inch or so of diameter, and it will be there. All right, so that's something else to consider. So this max spindle speed, we'll probably go back and change the feed rate, maybe cut it in half. But that's one that even after we posted the code, that is easy enough to change at the control and then come back, make our adjustments into the program, and update. All right, so we said we're at 500, max spindle speed of 3,000, plunge feed rate of 5 thousandths. That shouldn't be too much if we're off the stock. And then inches per revolution, and constant surface speed. We'll stay with the 10 inch. We'll stay with the tool, and then we'll go to the roughing parameters. All right, so we can either go to equal steps or the auto, let it calculate, which is always kind of a little scary. How many passes do we want to take, and let it figure out based on the depths. Equal steps are going to be with the loading, but as again we get to the smaller diameters and we kind of max out on that constant surface speed, then I kind of expect that you know, maybe the last couple cuts on the diameters won't be exactly where they need to be. So let's see what we get with a depth of a cut of 100 thousandths. The other thing is this programming, the question coming out of the software, is this programming radially or diametrally? Is it taking 100 off of one side, 200 off the diameter, or is it taking 50 and 50? All right, so we need to look at that in the code as well. If I see it going from 3.25 to 3.05 to whatever, then we're at 100 thousandths of a pass. All right, so once I've determined the post, the machine, what I'm telling it to do, then we can kind of refine these numbers further along. Stock to leave in X for the roughing, 10 thousandths and 10 thousandths. We have an entry amount of 100 thousandths as well. If we need to change the roughing direction, so this is just starting and moving along. This one is starting at the center of the part and moving out. Interior, and then there are the two that say come in this way, as opposed to, or cutting axially as opposed to linear along Z. And then zigzag straight and zigzag downward. All right, so if you're taking really light passes on material, you possibly get away with that. I have reservations about plunging that insert at the end of the pass and then back dragging it across the same face. All right, it's going to speed up the operation if I can get away with it. If the material will accept it, that's one thing. But I'm not trusting it on my first article. Just once we get into production, we want to do an experiment and try one. Okay, maybe. But let's see. We got the lead in, lead out, and so the lead in is set to 180 degrees, and so it's just going to feed in off of the stock 100 thousandths. The lead out is at a 45 degrees and length of 100 thousandths. So we need to see what this does. And so the first pass at 100. And we're coming to the end. It's showing the nose radius for that tool. It backs off at the 45 degree, comes in and takes the next pass. All right, I'm going to step through all of those, and then pretty much where the tool and the approximation, you can kind of see the variation in the stock. That's calculating the nose radius on the tool. All right, so when we come in with the finish pass, since we didn't include radiuses in these corners, even if we have a minimal finish tool, it's going to have some type of nose radius. Very few will be exactly sharp. All right, so to the finish. And let's see if we have a last. I can pick last. All right, so it picks up that last set of groups that we selected for the chain and says we're going to use the same profile. We go ahead and accept. All right, so let's switch to a smaller one, and then if I double click on any of those, it's going to show me it's at the 35 degree. The angles, the thicknesses, 1/64th corner radius, so about 15 thousandths, not quite half a millimeter. So I think the smallest they've seen is 4 or 8. You can get pretty tight depending on the geometries. So we'll just say that this is a finish tool. And for the finish pass, the feed rate at 5 slows it down a little bit. For aluminum, I think we're going to be able, if the spindle speed is there at 500, it's going to be able to finish in that same range. And let's see, we didn't need any of those. Finish step over then at the 100 thousandths, number of finish passes. So if you need a spring pass, if you're generating that tool pressure and you're getting taper and you want to make a couple spring passes, then number of finish passes. Stock to leave in X, none. Stock to leave in Z, none. And then the same thing with the lead in, lead out. It's going to make the approach and then retract it to 45. Okay, so this is going to kind of run into the nose radius of the previous, but it'll overrun it enough. And then I really didn't tell it to overrun, which is why we've got that that large kind of gouge there. So going back into the lathe, just like we would in the mill, you know, I notice something and I look at the perimeter, the parameters, and then we'll go back in and we'll make the adjustment. So looking at the lead in, lead out. On the lead out, we have a length of 100 thousandths, but that is the back. I can extend or shorten the end of the contour, and maybe I want to overrun that by, let's see if that was, I didn't check the nose radius, but let's go by at least 60 thousandths. All right, we update it, and then we go again. And then the finish tool now, this is overrunning for the rough. Now the finish tool is stopping right at the edge of our stock. All right, so considering that I'm probably going to put a cutoff tool in here to part this, well, this is still a pretty good chunk of material. I'd rather take it over to the bandsaw and horizontal bandsaw and chop it off, but with 2 or 3 inches of material on the backside, yeah, we'll see. All right, so part of our workflow, our process is to determine how to manage that stock. All right, so parameters. We'll go back into lead in, lead out. I gave it 60 thousandths previous. We'll stay with the 60. Okay, accept. Regenerate. And doesn't look there. Yeah, looks like it went a little bit past. Hopefully that wasn't the... Oh, it was. That was the lead in. There we go. So I saw a little bit of, thought I saw a little bit of difference, but all right. So now we're overrunning it for both the rough and the finish. So technically the part's through. We can go out and generate. Let's see, let's go ahead and regenerate. And then to look at the simulation, we pick up the front, or the toolpath group. And then we have the stock. So the importance of setting up the stock and the chuck jaws is that's where our simulation. If we're looking for collisions, if we're going to be working close, then we're going to be able to see what the geometry looks like. Okay, so I want to introduce the drilling operations early. So as an option, if you want to drill and tap, we're going to go ahead and put in a drill operation. All right, we need to find the right size. So a little bit of everything. All right, so let's just select the library tool and oh, they actually put in an end mill for that one. All right, so most of these look like, well, they wouldn't be an insert for a 1/4 inch diameter. All right, so let's get one close. And a similar tool, spot drill. Oh, that's what they were picking up, was a spot drill. Already exists in the tool list? No. So let's go back and find it. Spot drill, center drill, and then it goes up to the drills. All right. Okay, so for the spot drill, 10 thousandths inch per revolution, RPM. Well, we need to calculate that. 200 is going to be a little on the low side. Would probably run that somewhere between 1,000 and 1,200. And still a max spindle speed of 3,000. And simple no pec. And so a depth of minus 0.25 will open it up. This time I'm not going to include the drill point for the center drill. I'm not really concerned about the angle. Clearance of 0.25 with a retractive 0.1 if we did the pec. And we're just doing the standard drill, not really worried about a dwell. Okay, so even though I haven't drawn the whole geometry, it's going to start to put in that geometry. Okay, another drill. So let's go down. All right. So we don't have much in between. Let's go into the library tools again, see if there's another selection. Well, let's go to the filters. All right, so filters for the drill. Carbide coatings, well, let's go ahead and see what it gives. No, pretty much stayed in. All right, so I was looking for something that would be like the 5/16, so we could do a 3/8 16 tap. And if I go ahead and say add another, then let's see what combination it put in for that. It put it at the end. Okay, so said I was looking for a 5/16. So I'm just going to overwrite. I picked up the number. All right, so the tool geometry 0.3125. And, oh, that was the shank diameter, 0.3125. 118 degree drill point. And again, it would stay with 118 even if you're picking up 135 for a screw machine or a drill. That the 118 will be a little bit deeper, but it'll always have the clearance. Right? If you tell it 135 and pick up 118, it's not going to. The shoulder is going to be a little bit shallow of where you wanted it to end up. Not concerned about the holders, parameters, feed rates. We'll go ahead and set those. All right, so let's see, it overrode something there. So it must be in the description. There we go. And I don't want to confuse it, so this is one place where I am going to make sure that I tell it it's a 5/16 diameter. I don't want that 3/8 showing up in the, oh, where'd it go? Don't want the 3/8 showing up in the description. And that's weird. All right, we'll go with that. And station number 123, probably not. Let's just stay with the station number 4 and go with the offsets. All right, so if we were calculating this, since it's high-speed steel, let's see, the 5/16 probably still be in that 1300 range, or the 1200 range. I'm going to go doing math in my head again, so definitely going to get in trouble with this one. All right, so for the depths, we have 5 inch of stock, so let's give it at least 2 inches. 3/8/16 tap is probably going to be able to go 1 3/4 inches without too much trouble. So drill point, we will run through, and then the drill tip compensation, no breakthrough amount, but I do want it to figure. Or let's see, was that the drill? Oh, select a point. No. Okay. So we told it to go 2 inches deep. I want the drill tip to be included. Then we'll go ahead and accept. And then one more, Lathe Tools, drill, and then we need to look for a tap. Drill tap reamer. So it didn't show up with very many taps. So I'm not sure which one that should be in library. So we didn't get a chance to look at the library. Let's see if there is anything for taps. All right, so if I switch libraries, let me run through that again, is the little folder in the upper right will let you switch libraries. And if I was making a common library, things that I used normally, then I would start to add some of these, copy them over into my tool library, into my tool crib, and get it set. So there's the 3/8/16. Go ahead and accept. And then, like we did with the mill, if I take the 16 and add a 0 on the end of it, I get 160. That would give me a feed rate of 10 inches per minute. If we go to a feed rate of 320, that would give me a feed rate of 20 inches per minute. That I'm pretty comfortable with. And it should be calculating it. Okay, I'm not sure where it picks that up. We'll have to verify it in the geometry, or where we tell it that it is a tapping operation. All right, so up until now it's been the drill cycles. Oh yeah, and I think I plunged that. So 2 inches on a 5/16, that's a little aggressive. Probably would want to peck that at least once. If not, do the reduction IJ and K. All right, so we're going to switch over to the tap drill, and when I tell it that it's a tap, nope, still didn't update. Maybe when I accept it. All right, so depth is not going to be the depth of the drill. So if we go to -1.5 or so, that's going to be going to be about the length of the flute. So either the tap and the holder just ran into the stock, so that little stock modification because it wasn't long enough, or now let's just go ahead and modify it. Let's go in 1 inch, and then now it should look a little better. All right, so whatever was going on with the holder, yeah, we'll check it and make sure that we have that much length before I go driving it in more than 1 inch. All right, so going back to the parameters one more time, let's go ahead and tell it to do a chip break or a peck drill. Let's stay with the peck drill. And first peck, let's go for a 1/2 inch, and then subsequent pecks could be for a 5/16, 1 times D would be 320. Let's do half D at 0.16. Oops, I got an extra point in there. All right, and regenerate. Okay, so drilling operations don't require the geometry. We're not having it follow any profile. You can pretty much drop those in at any time. Let's go ahead and simulate one more time. And then pretty much all we see. So that's kind of what happened with the tap drill, is the ER holder or whatever type of, call it, retaining system that they have drawn up for that tool. That's as deep as it can go without running into the material in the stock. Okay. So last one, we'll do the post. Go ahead and give it a T1. All right, so we'll see what kind of so surface feet per minute max, and then stay at 500. And then we said we were going to look for, so this is the facing operation. I didn't come off of the 10,000, so that's still pretty aggressive. Let's see, where are we getting for the depths? From 6, and then it's going to an X value and a Z, so that's the retract. And so from 6/8, a little bit of clearance, so the 6/8, and then the next one, oh yeah, that's where it's picking up the clearance. All right, so I'm not sure why this post is putting in K values. So that's an interesting number where they're picking that one up.
Swing and radius is around those 250 radius corners.
Oh, that's right, because they shifted over. Okay.
Yeah. That way it's not leaving steps.
Right. Interesting.
Makes finishing a little bit easier.
Right. Yeah, anytime you're not going over, you stay with the 100,000 stair steps are going to be pretty crazy. All right. G1 to Z, and the 189, 167. All right, so I'm out of sequence as far as, yeah. Okay.